Hi guys, this is Reshma, and guys, we need to find the particular solution for the given differential equation, right? So guys, if you know the equation, you can see that it's a linear differential equation. So guys, this is the form of linear differential equation, right? This is how it looks: dy by dx plus p into y is equal to x, where p and q are function of x. So guys, that's how the linear equation is. But we can also, like, the linear equation can also be seen in this form, right? It is dx by dy, we differentiating x with in terms of y, and then p dash y, sorry, x into q dash. Guys, here p and q, sorry, p dash and q dash are the functions of y, okay, are the functions of y. So let's see. So to begin with, what we are gonna do, we will rewrite the equation, okay, rewrite the equation, given equation, in linear differential form, so that it's more easier for us to understand it, okay, understand and solve it further. So proceeding, first we'll start by dividing both sides by 1 plus y square, okay. So on the left side, when we divide, this is how it's gonna be, and on the right side it will become 1, it will cancel out, right? 1 plus y square as we are dividing. So now guys, next step is dividing both sides by dy, okay. So when we divide both sides by dy, on the left side we won't have the dy term, right? It will only be the tan inverse term divided by y square plus this term, right? And on the right side we'll have dx by dy. So guys, now what we'll do, okay, now what we can do is that we will move on term so that it looks more like a linear equation, okay. We just moved, like, x by y, 1 plus y square term, we moved it, okay. So this how it will be, like, after the step we just okay. And this is the p dash term, guys, okay. This is p dash. I made one mistake, let me change it, one sec. That is that I am just out of habit. So guys, it is y in here, right? It is tan inverse y. I wrote here, I missed the y, okay. So now what we are gonna do, we'll find the integrating factor, right? So guys, what is integrating factor? Integrating factor value is integral of p dash by dy, right? Guys, why it is dy? Because we have, like, our linear differential equation is in the form of dx by dy, right? So we have the function of p as a like, y, p is a function of y, right? So we will differentiate in terms of y. So p dash is 1 plus y square, right, into dy. And guys, this is the formula we'll be using, okay. This is the formula for integral. So it is tan inverse. Now substituting it here, we'll get e tan inverse y, right? So what's the next step? The next step is that we multiply the integrating factor to the given linear equation, right? Linear differential equation, tan inverse y dx by dy plus e to the power tan inverse y divided by 1 plus y square x tan inverse, okay, here also I wrote x, habit, y into e to the power tan inverse y, right, 1 plus y square. So guys, till here we have the usual thing. So now we can write on the left side, the term can be written as e to the power tan inverse y into x, right? And here it will be the same, tan inverse y into e to the power tan inverse y divided by 1 plus y square. So guys, now what we are gonna do, we will integrate both sides, right? Let me integrate both sides. So it will be tan inverse y, I will write x here, so this, and integrating tan inverse 1 plus y square, this is y square, guys, e to the power tan inverse y plus c, right? So guys, on the right side you can see like the terms are a bit like heavy, big. So to reduce it down, what we are gonna do is that we'll assume tan inverse y, let tan inverse y be t. Okay, so the differentiation of tan inverse y is 1 plus y square, guys, into dy is equal to dt, right? So continuing, this is x tan inverse y is equal to tan inverse y is t, right? We are changing, guys. On the left side also you can change if you want. Okay, so and this is t and sorry dy in here. And guys, if you see dy by 1 plus y square is dt, right? So we have substituted the values now. So now we'll integrate. We'll be using guys, integration by parts, right? This is the integration by parts formula, guys. Okay, so how we do that? First we will integrate, let the first function be t and the second function be et. Okay, so first it will be t into integral of et is et minus integration whole of first the differentiation of t, that will be 1. Okay, 1, I am just starting as it is, and then the integral of et is et, right, into dt. So guys, now this is plus c, I am missing that. So now it is et minus the integral of et is, guys, et itself, right? So this is what we have. So now let's substitute the value of t, guys, as we have integrated it. So t is what? Tan inverse y, right? E to the power tan inverse y minus e to the power tan inverse y, right, plus c. We can rewrite this as, we'll be shifting all the terms on one side, so it will be e tan, one sec, tan inverse y plus e to the tan inverse y minus tan inverse y into e to the power tan inverse y is equal to c, right, guys? So this we can take e to the power tan inverse y as common, and we'll get 1 plus tan inverse y plus, right, sorry, is equal to c. So guys, this is a solution, but this is a general solution. We need a particular solution, right? So to find the particular solution, what we'll do, we need to find the particular solution when x is equal to 0 and y is also is equal to 0. So now let's substitute the value of x and y as 0. So it will be a tan inverse 0 into x is 0 plus 1 minus tan inverse 0, right? Y is 0, that will be C. So guys, tan inverse 0 is 0, okay, and this will be 1, and tan inverse 0 is 0, that is C, and e to the power 0 is guys 1, right? So we'll have 1 minute. So the value of C will be 1, right? So now let's write the particular solution. The particular solution will be e to the power tan inverse y into x plus 1 minus tan inverse y is equal to 1. That is the solution, guys. Thank you.